Hello, everyone. Good morning, good afternoon, good evening, wherever you are, whatever you're doing. My name is Brandon Joza. I am a Tiger team member on the TME team. That is the Telco Media and Entertainment Group within Red Hat. I will say at the very beginning, this is not a pitch. This is just simply a video on awareness for OpenShift Virtualization, which also happens to be KubeVirt. It's built on top of KubeVirt. So I want to show folks with this video what it would look like if you're deploying, in this case, a FortiGate firewall. And also what I'd like to do is use SR-IOV for the interfaces as well. So we're going to cover all that in this video today. So what I'm not going to be doing is, like I said, not pitching on OpenShift Virtualization or the benefits of OpenShift Virtualization. I'm simply going to get into the tech and how to do this. So let's start with the architecture in this case. So the architecture is going to look very similar to an untrusted and a trusted architecture, where a security device, in this case, a FortiGate firewall, a virtual firewall, is going to be separated by two interfaces on the same network card. So in this particular case, I've got a network card that's in PCIe bus or in PCIe slot 4. And then I've got a NIC here, which is 0 and F1. What I'm ultimately going to do is explain how to do the deployment for OpenShift Virtualization, how to make this a little bit easier in terms of the networking, and then to deploy the FortiGate firewall itself. And then I'll also be getting into kind of the meat of the deployment itself. And I'll show you that really under the hood, at the end of the day, this is running KVM. KVM is fully supported by multiple enterprise firewalls, and FortiGate is just one of those. So what we're going to end up doing is we're going to do a test, an iPerf test. This isn't exactly perfect. There's a little bit of degradation with iPerf, but we'll see. We'll still get over 20 gig through this link. And what this is going to display is an end user that's going to be in the Charlotte office here, that's hanging off of VLAN 25, going through the trusted interface, this F1, through the FortiGate firewall, out the untrusted interface, which is going to house the DMZ, and in this case, the internet. So we're mainly going to be working in VLAN 25 and VLAN 55, but we'll be traversing two interfaces, and those interfaces are using SR-IOV. So let's have a look. First thing I want to do is go into, make this a little bit bigger. First thing I want to do is, one second, is go into installed operators. And you'll want to deploy the SR-IOV operator in this case. And if we look at all instances, there's two primary instance types that we're looking for. One is the SR-IOV node network policy, and the other one is going to be an SR-IOV network. The SR-IOV node network node policy, you'll notice there are three of these. One is for an E810 card that I have that uses the ICE driver, and then I'm also configuring a 710. So this is going to be a XXV 710 DA2. So there's two actual physical ports on that NIC. And in this case, what I'm doing is I'm configuring functions 0 through 31. So I'm taking up half the functions on the card for SR-IOV. And I've got my device ID here, the vendor, and then I'm naming this object. And you'll also notice that this is a namespace, which means that, the namespace is going to end up being in the network itself. We'll talk about that in a second. But what this means is that you can have multi-tenancy for your VFs that you create. So if you have multiple groups that need to support, let's say, multiple VFs or VNFs, then they can do that separately with full multi-tenancy. Where that comes into play is when we go into all instances and we look at the SR-IOV network, like in this case, if we go to Charlotte, then you'll see that this is actually being deployed in a Jinkit-VMS namespace. And what I'm doing is I'm assigning a resource name here. And the way I've got this interface, or I should say this resource named, is We're on slot 4, obviously. We're using port 1 in this case. So this is our trusted interface. And we're using 0 through 31 VFs for this card. Or I'm sorry, for this object. Then we're on VLAN 25. And in this case, we're using an IPAM policy of DHCP. But DHCP is simply coming from the firewall in this case. So the firewall is going to be doing literally all the work for us. Now, another thing that's you may be really interested in too, if you go up into Home in the API Explorer, and we look up the performance profile, what you're going to see is we have a performance profile. And in that performance profile, this is what dictates what additional kernel args we are going to configure. So in this case, IOMMU, we obviously need that. But you may also want to configure huge pages. You may want to isolate your CPU cores. And you may also want to do some advanced NUMA configuration here. You could do that. You can also determine if you want a real-time kernel. In this case, we obviously don't for performance reasons. I wouldn't be advised in this case unless you're doing like a VRAN. I'll get to that at another video. But you also want to do your configuration here. And so that's how you're going to configure your additional kernel args, NUMA, etc. With that, once SR-IOV is deployed, what you're going to notice is you've got your network policies that are going to be, you've got your network attachment definitions that are going to be tied into that namespace. So in this case, I'm in all projects. You'll see as a global cluster admin, you'll see all the objects that are deployed in this case. So you can see I've got the E810 card that's defined in here. And then I also have the 710 defined for several different things. Primarily, again, it's for the, in this case, it's going to be for a VNF, a firewall. We'll also configure a little bit of SD-WAN in here too, so you'll see that as well. So the next thing that we'll need to do, once that's configured and ready to go, now what you're going to want to do is prepare the FortiGate license and let's say your instantiation config. So what does that look like? So if we go over to the command line here, what I've got is two really important files. So let's go, again, we've got two firewalls that we're going to be looking at. And we've got this CloudNet. The CloudNet is going to be a multi-part mixed MIME for user data. That is going to get deployed to the firewall at the time of instantiation. I'll go over how that's all configured. But in essence, I'm going to show you how to create this file. This includes two parts. So this includes the config, and you'll notice this is quite large because all I did in this case was I ended up taking a backup, and ended up taking a backup. And so we've got our license here, and then we've got, in this case, this is a short config. And then I also have a much larger config taken from a backup. So we'll get to that. So what I'm going to do is go to a Fedora-based system. So then I'm going to go into this repo here, or this folder here, sorry, and go to Fortinet 02. Can't type today. Now there's two files in here, the CLI commands and the license. The license, you can see part of it. It's not much. You're going to be familiar with that. It's just an eval license in this case. The other one is going to be the CLI commands. So what you notice is this is a backup. You can tell it's a backup because this is the backup version. It's going to tell you the user, etc. But this is pretty large. This whole thing is really, really large. So what we're going to do is take this and we're going to use what's called write MIME multipart. Now that's being provided by a package. So if I were to do a sudo yum provides write MIME multipart. 1 second. I do make this a little bit easier because I've got it just. All right. So this is provided by QCOW. So if you wanted to, You can install this package, and then you're good. We already have it installed, so what we're going to end up doing is we're going to be writing this out in this case. And the way this works is you're going to use the command. You're going to output to a file. In this case, it's going to be a cloudinit.txt file. You're going to input both of the files, and that's going to create your multi-part file, right? So here's your CLI commands, and this is the license. This is what we had up above. We're going to run that. It looks like we got a warning here, but we're actually okay. It's just sort of complaining about syntax. But what we're going to get is a cloudinit.txt file. And in the cloudinit.txt file, it's exactly like what I showed earlier, right? So it's going to be a content type, multi-part, mixed. And that's going to be what we use to deploy the config to our firewall. Now, if I look at this directory here, there's a couple things I want to really zero in on. The first is, how do I get these secrets here, right? This is a pretty large secret. In fact, in this case, Vim can't even process it. It's really, really large, because if you can imagine the entire backup for a FortiGate firewall, that's large, right? And what we need to do is put that in a secret, and then that secret's going to be base 64 encoded. So what we're going to do is create a secret with that. The way we create a secret with that is we say, okay, I want to create a secret. So I'm going to do an OC create secret. It's a generic type. I'm going to call it a name. And then what I'm going to do is I'm going to give it the file that I want to create that secret from. Now, there's two parts that's really important here. You're going to see from file equals user data, and that's really, really important. And then you're going to give it the cloudinit.txt file. You're going to run that, and that's going to create your secret. So if I look here and I do OC get secrets, first, let's check what project we're in. So OC project, that'll tell us that we're in the right namespace here. And then if I do an OC get secrets, what we're looking for is this right there. And we've got that deployed. So we've got 2 and 3 deployed. If we want to look at it, it's OC edit secret. It's a large file, right? So that includes what we need to reference when we do our deployment. There's one other thing that's really important too, okay? And that is, how do you get a QCOW image into a registry, or how do you get it to a place where OpenShift can actually consume that? So I'm going to show you. If I go to Quay.io, go to my account, this actually is, and you'll notice this is a private repo, and I'll get to this in a second. But what I've done is I've created a container, and all that container has is the QCOW 2 image in it. That's it. It's really that easy. I'll go ahead and post something in the description of this video that shows you how to create that. That's a little bit out of scope for this. But all that is the QCOW image that's in a container, and then you're essentially telling it to allow it to expand and contract the volume. That's it. So what's going to end up happening is when OCP, like OpenShift Virtualization, gets that image, it's going to open that up, look to see if it's a raw image, and it's going to use that the same way that OpenStack would. And then it's going to take that file, and then it's going to deploy your firewall. So that's the one part. But how does that get referenced? So what I'm going to do now is show you, in this case, one of the firewalls that gets deployed. So if I look at there's a couple things that you should pay attention to. Number one is the storage. Number two is the CPU cores. Number three is going to be the memory here. And then you've got a mapping relationship between the NICs that you want to grab, and then any, let's say you want a predictable MAC address. You don't want to disrupt the network too much. You want to reuse the same MAC address. You can use the same MAC address. So I've got MAC addresses posted here. I've got MAC addresses that are configured here. Now what you'll notice is we've got a name, the MAC address, we're using VirtIO, and this tells it that this is an SR-IOV interface. Now we're using Multis, which is essentially a shim to create multi-NIC interfaces. So essentially, it's just doing the mapping from the SR-IOV network into what is ultimately a pod that creates the virtual machine, is how that works. Then what we have here is the secret reference. So this is the secret ref. This is for our cloud init data. So this is the name that we looked at earlier, which populates the config for the firewall. And that's where things get really, really cool. This is more on the Fortinet side than it is on the OpenShift or Convert side. But there's a really cool test we're going to do with this in a second. The other thing that you'd be interested in too is, okay, I showed you that this was a private registry here. So how do you get to it? How do you tell OpenShift where to go find this? So we're saying in this case, the source is going to be a registry. And remember, I told you that the container just simply wraps up the QCOW image. That's it. Here's the actual version. So I'm using 7.2.4. So I'm just mapping the version of FortiOS with this. And here are my credentials. So if I want to create my credentials, what does that look like? So that ends up looking like this file here. And what you're going to do is create a secret, name the secret, tell it which namespace it's in. Make sure you include the label app, this containerized data importer here. So that label is going to be a mapping relationship. Then you're going to give it an access key ID and a secret key. The access key ID is going to be your username, just base64 encoded. The secret could be just your password, and that's base64 encoded as well. Those aren't real. You're welcome to try and look at them if you want. They're real words. They're just not real passwords. But that's it. So what I'm going to do now is show you a little bit more about the environment. So we already said that desktop 25 or VLAN 25 is here. It's this user. It's PC 25. What we're doing is simulating this host, which is getting a DHCP address from the firewall when that comes up, just to give a little bit more complexity to the lab in this case. We're going to act like there's an application. The application's simple, right? It's just going to be a network test. So this is an iPerf server sitting in a DMZ on VLAN 55. So what we're going to do is ultimately, as the user, go through the trusted interface here, through Fortinet, through the Fortinet firewall on port 4, and then out port 2, and that's going to go to the DMZ in this case, okay? So what we'll do is we'll go to this test op real quick. It's already configured. And I'm ready. I just can't access the firewall. There is no firewall. Additionally, I can't get out to the internet. There's nothing there. I don't even have the default gateway, which I'm sure you would expect, or else I wouldn't be doing this. But I got 192.168.25.1. That's not there, right? Everything's unreachable. There's nothing for this host to grab. So what we'll do is we'll deploy, and it's going to be these two right here. So we'll do an OC apply F for the file, O2, and O3. And what we'll do, we'll watch these virtual machines come up. They're going to come up as FortiOS 2 and FortiOS 3. They'll happen so quickly you can barely see it. So they're there, FortiOS 2 and FortiOS 3. Now, what I'd like to do, this is going to take a second to come up, but what I want to go do is look at these pods for a second, and I want to show you something a little bit deeper. So in here, we've got this container that's being created, an import container. What that's doing is it's going out and grabbing the image, is using the secret for the registry that we have configured, and it's going to do the import of the QCOW image and process that QCOW image, make sure that it can run it, do some tests, etc. And then it's going to pass that to another container that's going to essentially be running similar to a pod. It's just a running pod at the end of the day with backed storage, right? So if I were to go OC get pods, what you're going to see here is we've got a launcher for these others. And what we're waiting for, if we do a watch, is we're waiting for a launcher to appear for FortiGate and FortiGate. And now it's creating these virtual machines, okay? Now what I'm going to do, this is going to start here real quick. But the reason why I want to grab this is because I want to look at the XML file for the KVM machine. So if I do essentially RSH, so I'm going to remote SH to the machine, I can do an XML dump on that host. And what we're going to see here real quick, the reason why I'm showing you this is because the license is going to get applied and then the config is going to get applied. So that's what's happening here. The VM license was installed successfully. I'm going to now go to this virtual machine. There's a lot of stuff going on here. But what I'm going to do is I'm going to keep this running on an external host, right? And I'm going to wait for that firewall to come up. But if I do, let's say an OC RSH for this pod, and I do a, actually, hold on 1 second. Yeah, that's it. If I do a verse dump XML, it's KVM. At the end of the day, this is simply KVM, the stuff that everybody is used to and what many vendors support, KVM, right? So now you can tell kind of how this works. Underneath, there's KVM, and then a pod orchestrates the KVM workload. It provides the image, it provides the networking. It just kind of plumbs everything in. And then that allows organizations to simply kind of move in between this stage between a walk and a run. So let's say, a vendor doesn't have a CNF ready, but they have a VNF. This is a perfect use case. But now you can take that a little bit further. So we can see that now we're pinging, a Google DNS server. That's great. But you can take this further and you can do a complete GitOps deployment now. You can house your code in a Git repository, and you can use Git webhooks and Argo CD to deploy the bare metal server itself at an edge location. And then on top of that, these are just essentially OpenShift Kubernetes manifest, right? For KubeVirt. Now you can deploy the VM after everything has been deployed. So you're essentially, the only thing you start with in this case is a Redfish IP. So there's 2 DRAC examples I'm providing here. There's 2 ILO examples. I use Sushy-Tools. So I've written a blog here that talks about how you can use Sushi emulation that will simulate bare metal for virtual machines. Highly suggest you check that out. But you can use this to essentially deploy your entire infrastructure, bare metal from soup to nuts, absolutely nothing, just a simple DRAC. That's it. No OS installed. And OpenShift can get deployed, and then it can automatically deploy your VNFs. It's perfect for a universal CPE use case. It's perfect for an edge deployment use case. You use this for vRAN, you name it. This opens up tons of possibilities. So what I'm going to do here is I want to show that the firewall is not only configured, but we've got some cool things going on in here. Username and password is exactly what we thought, because as we expect it should be, right? But then also, like, what if you wanted to deploy your SD-WAN automatically? That's pretty cool. We could do that. The firewall policies, we wouldn't be passing traffic if we didn't have at least some firewall policies. So we've got some policies. So LAN can get to the DMZ, DMZ can get outbound. LAN can get outbound, etc. We're passing traffic. So the cool thing now is, let's say we've got another virtual machine in here. Let's say we wanted to test that application, right? So here we're just running iperf, and let's say I want to run iperf. So if I want to run iperf to this host, now I can run iperf to this host. You'll notice getting pretty good transfer rate on this. I have done zero tuning whatsoever. The only thing I did is I allowed jumbo frames on the firewall, obviously configured because Fortinet allows us to configure that. So jumbo frames are configured on the firewall, but other than that, I haven't configured anything. It's all being done with CloudNet. It's all being done by a single Kubernetes manifest, and that's it. And this is what I wanted to show you, that the power of running KubeVirt or OpenShift Virtualization, here you can see we've got some traffic on here now. The power of running OpenShift Virtualization for your VNFs while you're waiting for vendors to create their CNFs. This is a very powerful tool. And this is what I wanted to show you today. If you have any questions, please like, subscribe. You know all the things to do. I'm just a little guy. I'm just showing you all how to do this. So please let me know what your thoughts are. You can @ me at Twitter, and I'll talk to you soon. Take care, everyone. Bye-bye.